Today we're reviewing limits, and I want to start by just very briefly going through each type of problem. Starting with factor and cancel. That's the most common type of limit question. Is that you can factor the top, factor the bottom, see what cancels, and then see if you can plug it in from there. And the easiest type even before factoring and canceling, I didn't even bother putting it up there, is direct substitution, where you just plug it in and it tells you the limit. It just works. They actually had, a couple of years ago, they had a question that was just, you plugged it in and it worked. Yeah, like an FRQ. Yeah. But usually it does not. The one they put on this year was L'Hopital's rule on the A version, which we will do next week. So factor and cancel. That's usually if you got a quadratic on top, quadratic on the bottom, something like that. Factor and cancel and see what you get. Conjugate. Remember, conjugate. If I have A plus B, then the conjugate is A minus B. That's most commonly used. That's most commonly used for things like if I have like a square root of x minus 3, and then I have like x minus 9. If I'm finding that limit, then the way that one way we can do that is by multiplying top and bottom by square root of x plus 3, which will give me that difference of squares, so that no more square root, and then the x minus 9 will be on the bottom and cancel with the x minus 9 on the top. So that's multiplying by the conjugate. Usually if a limit has a square root in it, then that's what you're going to be expected to do. One side, I'll come back to this one when we talk about continuity. Limits to infinity, a lot of times I call this races to infinity. So if I'm talking about what happens as x gets really, really, really big, or what's happening when x gets really, really, really small, like we've had questions where it's talking about like e to the x. As x approaches negative infinity, well, e to the x, as I get really negative, is going to give me negative exponent. Exponent's going to put it on the bottom and get our y value closer and closer to 0. Or we can talk about like a polynomial versus an exponential. Who's going to win? Well, the exponential is going to win if we're talking to positive infinity. Limit definition of a derivative. That is f of x plus h minus f of x all over h. Limit as h approaches 0. So if you see, they like to throw this on multiple choice. So if you see, especially a limit as h approaches 0, if you see this structure, you should be, instead of thinking about limits, you can do it with limits, but really you should be looking at that and recognizing, oh, that's asking about the derivative at a particular point. Then we have L'Hopital's rule. To use L'Hopital's rule, we need to check two things. Thing number one, is the function continuous and differentiable? And thing number two is the limit of f0 and the limit of g most of the time. You can also have like infinity over infinity, but some kind of indeterminate form. And you need to check both the top function and the bottom function separately and make sure that both of the limits are like a 0 or an infinity or something like that. So you check the limit of the top, check the limit of the bottom, and then once you do that, if both of those are true, then the limit as x approaches c of f over g equals the limit of f prime over g prime. F prime over g prime. So I can take derivative of top. That's not the quotient rule, right? It's this particular rule that says I can take the limit. I can take derivative top, derivative of the bottom, and then take the limit. That's at both the top and the bottom give me an indeterminate form. 0 over 0, 0 over infinity, something like that. A couple of you actually, on the last test, there was a limit that relied on what I was expecting people to do was to factor and cancel, and then you could plug it in. But another way that I saw people do it was with L'Hopital's rule, because it gave you a 0 over 0, and so I could just take derivative top, derivative bottom, and then I could plug in my number. And then continuity. The definition of continuity is that the limit from for f to be continuous, basically it needs to be continuous means connected. So the limit from the left equals the limit from the right equals the value of the function at that value. So you can have the limit exist, but have it still not be continuous if it has some kind of a jump like this. Still not continuous, but the limit exists. So one common type of problem as far as that goes that we'll look at in just a minute is some piecewise functions, where it has you test it from the left side of the piecewise function, test it from the right side of the piecewise function, and then go from there to plug them in and make sure they match. And if they match, then the limit exists. If it doesn't match, then the limit doesn't exist. Or you can look at it from the graph and visually look to see if there's any kind of jump. Yes? Yeah, I can pull up one of those. All right. So let me start. I'll only do like one or two of these, but let me start with some warm-up ones for you. So let's try number 2. We're using whiteboards here. Have at it. This one should be a straightforward factor and cancel one. Ready? Okay. What do we got? Good. Good. Okay. So one of the things that on these factor and cancel problems, is that when I plug in 4, I get 0 over 0. So one of the clues is that since I have a limit as x approaches 4, that means that one of the factors that's going to cancel, that's preventing me from plugging in 4 right now, is an x minus 4 factor. So that kind of gives me a clue that, that the top is going to turn into x minus 4 times something, and the bottom is going to turn into x minus 4 times something. And then once that cancels on both sides, then I'll end up being able to plug in 4. That's what's keeping me from plugging in 4 right now. Limit as x approaches 4. And so x minus 4, this is x minus 4 times x minus 1. This is x minus 4 times x plus 2. So then I have limit as x approaches 4 of, now I can cancel these and plug in 4 from there. Make sense? Yes? Okay. Yes. Yes. How L'Hopital's rule would look for that one is that this equals the limit as x approaches 4. This is with L'Hopital's rule of derivative of the top over derivative of the bottom, and that's because these are both differentiable. The top is 0, bottom is 0. So you'd have to explain that out first, and then say, therefore, we can use L'Hopital's rule, and that equals the limit as x approaches 4 of that and that, which is 2 times 4 minus 5 over 2 times 4 minus 2. Need the same thing. Okay, one more of these basic, like factor it and cancel. And then we will move on. This one should be easier because it factors more obviously. So I'll give you a little bit less time on this one. Again, the fact that it's the limit as x approaches 0 should give you a clue as to what factor should be coming out and canceling. Answers. Okay, good, good. We should be getting -1 there. Let me give you a limit 1 to infinity. The wind.
I think this is what Kanye West was talking about when he said no one man should have all that power. He was talking
Sure.
about me
Talking about you.
closing my dry erase marker too hard.
Okay. I'm throwing some more challenging. This one's more challenging. This one requires you to.
Extra aspects to it.
Yes.
Yeah, it definitely does for show.
This one requires some logarithm knowledge.
They're definitely very difficult for show.
Let me adapt this here. One of the properties of logarithms that you should know is that the natural log of e to a power is, I can take the 4x and bring it out in front, right? And guess what natural log of e is? It's 1. So when I get really, really, really big, then it's going to keep being 4 over 1, which is 4. Next one. Hopefully we have spotted that this is a limit definition of a derivative question. Because as soon as you see limit as h approaches 0, then that alarm bell should be going off in your head that this is a limit definition question. F of x is e to the x. And so we're asking for f prime of 5. I know that because 5 is the number that's being put in where the x would go into this function. So we're asking for f prime at 5. Well, derivative of e to the x is e to the x, so plug in 5. Done. There's your limit definition derivative question. Okay. Multiply top and bottom by what? Square root of x plus 1 plus 2 on top and bottom to get some things to cancel. And you'd wind up with an x minus 3 on top that would cancel with the x minus 3 on the bottom. Okay. Let me zoom out so that I can scroll quicker here. Oh. I won't do one this way, but limit as, just a reminder that limit as x approaches 0 of sine of x over x So that's a limit that we learned and used to figure out some other limits involving trig. Let's do this one. Show that this function is continuous at 3. And are we good on the graphs? If I gave you a graph and asked for limit from the left, limit from the right. Okay. So I won't bother doing one that has that. On the calendar, by the way, while you're doing this problem, 2 things for you tonight. If you want some more practice with limits, then one of the AP live sessions that AP went and did was specifically on limits and continuity and all of those things. So if you want some more AP practice problems on limits, then there's a link there for you to get some more practice in beyond what we're doing here in class today. And then the other thing that I'm going to ask of you is that tomorrow is calculator day. Everything you need to know about the calculator. And I'm not going to spend too much class time unless people have specific questions. What I'm going to ask is that you watch the videos. I'm going to add a couple videos to the playlist that are quick, like 2 or 3 minute videos on how to do certain things that I have shown throughout the year. So how to store values, how to easy ways to solve an equation on the calculator, how to get the derivative, how to get the integral on the calculator. Do that. Make sure you have watched those and have that background so that you can come in knowing what questions specifically you have on the calculator. So that's what I'll ask you to do tonight before you come into class tomorrow. And then we're going to do some, we're going to work through, one of the things we're going to do is we're going to work through some volume FRQs, which should also give you practice on the calculator, because a lot of those are calculator questions. All right, talk me through what we do here to show that G is continuous. Okay. So put those ideas together here. We need to plug in, we need to put in 3 on the left. Look at the limit from the left, which is the top part of the piecewise function, the x squared minus 1. So that is 3 squared is 9 minus 1 is 8. And so then we need to make sure that the limit from the right is also 8. And so we need to make sure that this limit of this second function as x approaches 3 also comes out to be 8. Which, as you said, requires some factoring and canceling to get out your answer. It's x plus 5 times x minus 3, so when the x minus 3's cancel, I plug in 3, I get 3 plus 5 is 8. Therefore, it's continuous. All right, any questions on that? All right, let's take these last 5 minutes or so. How about the 2017 free responses? And we're going to start looking at a couple of those. Sure, I'll look at yours. What's your score out of 15 as of this moment on those? All right. If you haven't turned those in to me, make sure you get those turned in to me. All right. Here we go. Maybe. (2017). All right. This was me guessing point values. This isn't the actual point values. Those of you who turned it in, I did score yours, so I'm not going to go through the scoring guidelines in detail. I will point out one or two things. There's your Riemann sum. Since we're doing a left Riemann sum, we're going to use all of them except the rightmost endpoint. We're going to make sure we put units on our answers, especially since the directions said indicate units of measure. If it says something like that, or using correct units, or something along those lines, that probably means that they're specifically looking for, can you get the units correct? And they're taking points based on whether or not you have units in your answer. So make sure you have units there. We have an overestimate since it's decreasing. I have a picture here. Increasing and decreasing are what determine whether Riemann sums are overestimates or underestimates. And if you are ever stuck on which one is which, then draw a picture and see what you come up with. But a left Riemann sum means that it's going to take since we have a decreasing function, the left Riemann sum is going to take the highest endpoint of the two. Right? The leftmost endpoint will be higher than the one on the right since we're decreasing. And so that means that the rectangle is going to kind of overcompensate and have more. So our explanation is that we are decreasing on the interval. And it is an overestimate. Part C, since we have an area we're trying to get to volume, then integral of the area from 0 to 10. And since our volume is the integral of the area function, here's our h, here's our dh dt. And so when we do our related rates, derivative of the integral cancels out and winds up back where we started. And then times dh dt. Since we took a derivative of that integral involving h, that's where our dh dt goes. And then we're going to plug in our dh dt and our h to figure out what dv dt is. Cubic feet per minute. Again, they want units in that answer. So questions, any details that we need on that first one? All right, we're going to do like one or two of these a day.